Imagine looking through a telescope and seeing Jupiter. Not the swirling colors, not the iconic bands, not the great red spot, tearing across its surface like an ancient cosmic wound. Instead, you see a quiet, dry, colorless world, a pale giant stripped of its storms, Jupiter transformed into a desert, silent, stark, empty. Now hold that image for a moment. What would that even look like? A planet so massive that it could swallow more than 1,000 Earths, suddenly left bare. No swirling atmosphere, no thunderous storms, no constant motion, just a dusty and frozen emptiness stretching across a solid surface that the universe has never actually revealed. This is not a small change. This is a shift so dramatic that everything we know about Jupiter begins to fall apart. A transformation like this would not just rewrite Jupiter's story, it would shake the entire solar system. Start by wiping away everything that defines Jupiter. The dense clouds of ammonia, the violent bands that wrap around its body, the storms that churn endlessly, all gone. Imagine a surface that stretches farther than any desert in history. The Sahara, the Gobi, Antarctica's ice deserts. Combine them all, then multiply them many times. Jupiter's new desert would make them feel like small patches of sand compared to a continent. The shock comes from the silence. Jupiter has always been a world of noise, turbulence, chaos. Now it is quiet. The cloud bands vanish first. Those iconic colored stripes exist because of the constant rising and falling of gases in its atmosphere. Take those gases away, and you take away Jupiter's identity. In place of motion, you get stillness, dust, a faint, drifting haze. The hurricane-like storms collapse next. These storms rely on the deep layers of pressure and heat beneath the clouds. If the atmosphere thins out or disappears, the storms cannot survive. They flatten, they unravel, they fade like smoke in the cold. But the most chilling transformation is what happens to the Great Red Spot. When the last of the atmosphere disappears, the Great Red Spot does not explode or vanish in an instant. Instead, it collapses inward. The spinning gases lose their heat and their inertia. The color fades. The swirl unravels. What remains is a scar on the surface of this new desert. The region that once held the Great Red Spot might form a giant depression, a dust bowl larger than continents, a crater of unimaginable scale, a wound carved by the collapse of a storm that once shaped an entire hemisphere. If Jupiter becomes a desert, geological features finally emerge. Imagine canyons that stretch thousands of miles. The crushing gravitational force could create mountains of impossible height. The planet might have vast plains of compacted rock and minerals, layered by the remains of former atmospheric material that settled as dust. Deep below the crust lies something exotic, metallic hydrogen, a liquid so dense and strange that Earth chemistry has no real comparison. If the atmosphere disappears or thins dramatically, the pressure above it changes. That means the metallic hydrogen could expand, contract, or even destabilize. The entire subsurface structure of Jupiter might shift. This transformation would be far from peaceful. It might produce quakes on a scale no planet in our system has ever seen. A world cracking open under its own weight. Jupiter is not just a planet. It is a gravitational anchor. Its mass stabilizes the solar system. It steers asteroids. It influences orbits. It shapes the behavior of moons. Those perfect orbital dances around the planet could start to drift. The moons might wander outward, slowly detaching themselves. Some could become captured by the sun instead. Others could collide with one another. Next comes the asteroid belt. Asteroids could slip out of their usual orbits. More random trajectories appear. Earth would feel the danger almost immediately. Jupiter influences Earth's climate in subtle ways. Its gravity affects how Earth wobbles in its orbit. Even small changes to Jupiter's mass could shift Earth's long-term climate cycles. Glacial periods might become unpredictable. Seasons might stretch or shrink. The rhythm of Earth's climate could lose its balance. Gas giants depend on their atmospheres for identity. Without those clouds and storms, the planet becomes something new, something we have never observed, something we have never classified. For astronomers searching for exoplanets, this is a critical lesson. We often judge distant planets by their size and their mass. We assume anything Jupiter-sized must be a gas giant. But what if some of those worlds are stripped, desert-like spheres, ablated by their stars, eroded by cosmic radiation? This thought experiment cracks open a door. It expands the range of possibilities. It challenges our assumptions. It reminds us the universe does not owe us familiar patterns. Jupiter, the eternal storm, becomes Jupiter, the silent desert. And somewhere in that silence, the universe reminds us how fragile everything really is.